the Lycanthrope's log. The Lycanthrope's log. Okay, so Jax starts up his JavaScript interpreter and sets up the environment as needs. He needs to keep his journal and let journal and function at entry open parentheses events and squirrel and journal push and open parentheses events and squirrel, and note that the object added to the journal looks a little odd, and instead of declaring properties like events and events, it just give a property name, and this is shorthand that means the same thing. And if a property name in brace notation isn't followed by a value, each value is taken from the building with the same name, by the way. And so then, every evening at 10 p.m., or sometimes the next morning after climbing down from the top shelf on his bookcase, and Jax records the day, like this example now. And once he has enough data points, he intended to use statistics to find out which of these events may be related to the squarifications and correlation in a measure of dependence between statistical variables. And a statistical variable is not quite the same as a programming variable. And you typically have a set of measurements, and each variable is measured for every measurement, and correlation between variables is usually expressed as a value that ranges from 1 to 1, and zero correlation means the variables are not related, and a correlation of 1 indicates that the two are perfectly related, and if you know one, you also know the other. And negative 1 also means that the variables are perfectly related, but that they are opposites when one is true and the other is false. And to compute the measure of correlation between two Boolean variables, we can use the BHI coefficient. This is a formula whose input is a frequency table containing the number of times the different combinations of the variables and were observed, and the output of the formula is a number between -1 and 1 that describes the correlation. And we could take the event of eating pizza and put that in a frequency table like this, and where each number indicates the amount of times that combination acquired in our measurements, like this picture now. 76, no squirrel and no pizza, and 9, no squirrel and pizza. We have pizza here, no squirrel, yeah. Okay, so 4, a squirrel, we have a squirrel and no pizza, and 1, we have a squirrel and pizza. We have 2 of those. We have 2, a squirrel and pizza, yeah. And if we call that table n, and we can compute and using the following formula, and if at this point you are putting the book down to focus on a triple flashback and to turn great math class, hold on, and I don't intend to torture you with endless page of cryptic notation, and it's just this one formula for now. And even with this one, all we do is turn it into JavaScript. The notation indicates the number, by the way, of measurements, and where the first variable squareless, and in false is false 0, and the second variable pizza is true 1, and in the pizza table is 9, and the value refers to the sum of all measurements, and where the first variable is true, and which is 5 in the example table, likewise, and refers to the sum of the measurements where the second variable is false. And so for the pizza table, the part above and the division line, the divide end would the divide end would be 1 multiply 76 minus 4 multiply 9 minus 40. Okay, so and the part below it, the divisor, would be the square root of 5 multiply 85 multiply 10 multiply 80, or 340,000. This comes out to 0.069, and which is tiny. Eating pizza doesn't appear to have influence on the transformation.